Another one of the most important things that we can utilize to be able to help us evaluate trigonometric functions is a unit circle. And we've already seen the unit circle, and there's special sort of angles that occur quite frequently on the unit circle that are going to help us to be able to get exact values. There's really five values that are going to help us: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. If we can memorize these, the rest of the unit circle kind of follows suit because it just goes in a circular sort of pattern. So they're just going to repeat themselves. All right. So now we're not going to memorize all of these in just one sitting, obviously. But at some point throughout the course, we probably should have these angles memorized. Okay. So one of the things that we're going to do is if we find, so for instance, if we have an angle of 30 degrees, and we were to ask what is the cotangent of 30 degrees, then what we could do is we could look at this coordinate and we could be able to evaluate that because we're given the x and the y coordinates. And notice that these are all coordinates that are going to fall on the unit circle. Remember, the unit circle, x squared plus y squared equals 1. And so if I was to throw that back into this equation just to verify that at least one of these points falls in there, that would be root 3 over 2 square plus 1/2 square, right? And then root 3 over 2 becomes 3/4. And then 1/2 squared becomes 1/4. That's 4/4, which is 1. All right. So that's just showing you that at least one of these points, and you could do this with every single point, and it would fall on the unit circle. All right. So that's just verifying that they fall on there. I'm not asking you to do that. I'm just showing you all that these points, they do fall on the unit circle, and that's why they're there. And like I said, there's an infinitesimal number of points. I said that in an earlier video, but these are going to be some common ones because we know that special things happen with 30, 60, 90 right triangles, 45, 45, 90 right triangles, etc. Before we go through and do this, one thing that helped me to kind of help to memorize the unit circle, if I could, is I remembered that I would just go through in descending integer values. And I'd look at the x value, and I would think, okay, well, that's root 4 over 2. And the square root of 4 is 2 over 2, which is 1. And then the next one would be root 3, and then root 2, and it's all divided by 2 each time. And then this would be the square root of 1 over 2, which is 1/2. And this would be the square root of 0 over 2, which is 0. All right. So notice what happens. You get 4, 3, 2, 1, 0. And we could just go through and just go in descending order. And then it just goes back up. 1, 2, 3, 4. 3, 2, 1, 0. 1, 2, 3, 4. And it would just have that circular pattern. That's a way to memorize it. And of course, the signs are positive and negative depending on the quadrant. Okay. Or you could just memorize like the first quadrant and then kind of extend it to the other ones. And we're going to see this later in the course. But for right now, we should just get used to being able to read the unit circle, all right, to be able to evaluate trigonometric functions. All right, so let's do that. Let's just find some basic trig values. And we're just going to find the exact values using this unit circle. And we're going to rationalize the denominator if necessary. So we have sine of 45 degrees, right? So what we're going to do is we're going to go to 45 degrees, which is right here. We notice that the x coordinate is root 2 over 2. And we notice the y coordinate is root 2 over 2. We go all the way back up to those values that we memorized, or those definitions, okay? And we remember that the sine function is the y coordinate, okay? So like I said, the sooner we memorize these, the easier our lives are going to be. So if you haven't memorized them yet, what I would recommend is pause the video, make up some flashcards, and memorize these, okay? Otherwise, it's going to be rough going through the rest of the course. All right, so the sine of 45 is really the y coordinate at 45 degrees, all right? And if we look up here, that's just going to be root 2 over 2, okay? So that's it. That's literally all we have to do. We just have to look at the angle and then just figure out what the y coordinate. We remember that the cosine is the x coordinate at 4 pi over 3. So we're going to go into our unit circle. Okay, so we just look around and we're going to look at all the radial measures, the radian measures, and finally we get to 4 pi over 3. Then we notice that the x-coordinate is -1/2. And so this would be -1/2. Okay, don't try to put this into your calculator. This one would work out okay for you. This one would not. Okay, we would not get an exact value. All right, and I will be asking everybody to give me exact values as they go through the unit circle. So if you give me 0.785 or whatever the calculator might say, I'm not going to give you credit for that. We have the tangent of 11 pi 6, right? So remember, the tangent is the ratio of y over x at the point or at the angle 11 pi 6. So let's go in the unit circle. We find 11 pi 6, and we notice that x is √3 over 2, and we notice that y is -1/2. And so this becomes -1/2 divided by √3 over 2. Okay, so that's y over x. So this is the y coordinate. This is the x coordinate. Right? And so if I simplify this, that's going to be -1/2 times the reciprocal, which is 2 over √3. The 2's cancel out. I have -1 over √3. And then it did ask us to rationalize. Okay, so we have to get used to this rationalization. We're going to multiply by √3 over √3. If we do that, then this now becomes -1 times √3 is √3. √3 times √3 is going to be 3. All right, so that would be the rationalized value of tangent of pi over 6. Right now, you should certainly go in your calculator and check your answer. Okay, and in fact, let's do that really quickly. So if we go in our scientific calculator, first of all, we want to make sure we're in radian mode. Okay, and I'm going to say tangent of 11 pi over 6. Right? And if I do that, I get this number, -0.57735. Okay, so that's nice. Now, negative square root of 3 divided by 3 has the exact same value. So that's a way that we can check to make sure that our answers make sense. We go in our calculator and we just check these, okay, to make sure that they're the same value, okay? So make sure, again, the calculator must be in the radian mode, okay, if you're doing this. All right. Now, let's say we have something like this, the cosecant of 675 degrees. So we go to our unit circle and we're feverishly searching for 675 degrees. All right. And the highest it goes up to is 0 degrees or 330 degrees. It's the highest it goes up to. That does not mean that we can't find it. Okay. What we're going to have to do is we are going to have to find a coterminal angle. And moreover, we're going to have to find a coterminal angle between 0 and 2 pi, okay? Or 0 and 360 degrees, all right? So that's the trick. If it's outside of the unit circle's domain, what we're going to have to do is we're just going to have to find a coterminal angle. And remember, to find a coterminal angle, we just take 675 and we're going to subtract 360. And if we do so, that's going to give us 315 degrees, all right? So what we're saying is that the cosecant of 675 is really the same thing as the cosecant of 315. Now, we're going to go find 315 degrees on the unit circle, all right? And it's right here. We also remember that the cosecant is the reciprocal of the y value. Okay, so cosecant is 1 over y at 315 degrees. So we go up to 315. We find that the y value is -√2 over 2. All right, so now this just becomes 1 over -√2 over 2. Or that's the same thing as if we multiply by the reciprocal, -2 over √2. And then we're just going to rationalize this. And we're going to start to see that we might remember these after a while. Okay, we did this one in the previous video. So we multiply by root 2 over root 2. And 2 times root 2 is going to be 2 roots of 2. The negative comes over. Root 2 times root 2 is 2. Those cancel out. And ultimately, we're left with negative square root of 2. Of course, we should check this. So in our calculators, what we're going to do is we're going to go to the degree mode, right? And we're going to have the secant, okay, which we don't have a secant function. But what we can do is we can say 1 over the sine of 675, okay? Because remember earlier we said that the sine function and cosecant functions are reciprocals of one another, right? Now, the other thing we should do is remember our answer that we got was negative square root of 2, all right? So if we go into our calculator and we say negative root 2, there we go. We get the exact same numbers, okay? So again, that's a way to check your answer. Although we should never just rely on the calculator to be able to just evaluate these things, okay? All right, so one last example. We have the opposite of the cotangent of, cotangent of negative 13 pi. Once again, we don't go to our unit circle, and we certainly don't see negative 13 pi. So what we need to do is we need to get a coterminal angle that's somewhere in here. So remember, to get a coterminal angle in radians, we're just going to continuously add 2 pi. All right, so we're just going to add 2 pi. That's negative 11 pi. And then we add another 2 pi. That's negative 9 pi. And then we add another 2 pi, negative 7 pi. And then we add another 2 pi. And eventually this will end, negative 5 pi. Then another 2 pi, just a couple more times, negative 3 pi. And then another 2 pi, that's going to be negative pi. And then finally, if we add 2 pi to that, that's going to be pi. All right, and that's an angle that's between 0 and 2 pi. All right, so we might have to do it a few times, but notice it only took us about 10 seconds to do that. It's not that big of a deal. And so what we're saying is that the cotangent of negative 13 pi is really the same thing as the cotangent of pi. Now remember, the cotangent, since we memorized these, is the same thing as x over y at pi. So we're going to go up to our unit circle. We're going to look at pi. We notice that the x coordinate is negative 1. We notice the y coordinate is 0. All right, so that makes things easy. So we go back down here, and x over y is going to be negative 1 over 0, which unfortunately is undefined. All right, and it is possible that we could end up having these trigonometric functions that don't have definitions at certain angles. All right, so cotangent is not defined at pi. Of course, if we don't believe it, what we can do is we could say 1 divided by the tangent function of pi, right? And we want to make sure that we're in radian mode. And I want you to notice that it says undefined, all right? And that happens, all right? So just beware that we're not always going to get values for every single trigonometric functions at every angle. Sometimes it's going to be undefined. All right, so hopefully this helps you to be able to see how to evaluate the trigonometric functions, both that are on the unit circle and also those that are not on the unit circle. Now, in the next video, what I'm going to do is I'm going to show you how to be able to get all of the trigonometric functions, okay? But this, what we just did is extremely fundamental to this course. You have to be able to do this, okay? These sorts of problems, okay? On every examination that I've ever given in pre-calculus, these are types of problems that I have students evaluate, all right? So if you weren't able to do this after this video, you should go back, watch the video again, try doing some of the homework, okay? But again, this is fundamental to being able to do the rest of the stuff in the course.